Hi, in this video I would like to look at more examples of how we go about factorizing using the difference of squares. In the first video we said that to factorize using difference of squares, the expression must include two terms that are both squares. But what happens if the terms are not squares? What happens if we have something like this? X is a squared, but 8 and 2 are not. So what do we do now? One of the first rules we learned about factorization is that we must look for a common factor in each term. The aim here is to take out a common factor so that we will be left with an expression that contains two terms. Here we have a value of 8 and a value of 2. The only factors of 2 are 1 and 2. So let's take out 2 as a common factor. We can say 2 outside of the bracket. 8 divided by 2 is 4. So we have 4x squared. 2 divided by 2 is 1. So we have minus 1. 4 is a square. X squared is a square. And 1 is a square. And now we can factorize this bracket using difference of squares. So let's put our 2 outside of the bracket. Let's draw in our 2 brackets. The square root of 4 is 2, and the square root of x squared is simply x. So we have 2x over here, and 2x over here. The square root of 1 is simply 1. So we have 1 over here, and 1 over here. Now we can separate these terms with a minus sign, and these with a plus. Factorize the following. 125m cubed minus 45m. 125 and 45 are not squares. Neither is m cubed or m. So we know we need to look for common factors. 125 and 45 are both multiples of 5. So let's take out 5 as a common factor. 125 divided by 5 is 25. So I have 25m cubed. Negative 45 divided by 5 is negative 9. So I have negative 9m. Now my values are squares, but my variables aren't. So we still need to take out one more common factor. We know that if we have m cubed and we divide it by m, we'll get m squared. And here we have an m in this term as well. So we can take out m as a common factor. So I'm going to write down the 5 I've already taken out, as well as the m. And I have 25. M cubed divided by m gives me m squared minus 9. M divided by m is 1. So now I can close my bracket. Now in my bracket I have 25, m squared, and 9, which are all squares. So now I can factorize using difference of squares. Don't forget the 5m outside of the bracket. Let's open my first bracket and open my second. The square root of 25 is 5, so this becomes 5m. And again on the side. The square root of 9 is 3, so I have 3 over here and 3 over here. Let's separate these terms with a plus sign and these with a minus. And we've now factorized this expression. Factorize the following. 1 over 2a squared minus 8b squared. Now, our a and b values are squares, so that's fine. But we have 1 over 2 and we have 8. 1 over 2 is not a square. So in cases like this, we need to take the entire fraction out as a common factor. Let's do this now. We can say 1 over 2, open the bracket. 1 over 2 divided by 1 over 2 is simply 1, so we're left with a squared. When you take out a common factor, you are actually dividing. So we are saying 8 divided by 1 over 2. And remember that when you divide by a fraction, you actually multiply. So in this case, we're going to have negative 8 multiplied by 2, and we get negative 16. Don't forget to put in your b squared. Now we have a squared minus 16b squared. They are both squares. So we can factorize using difference of squares. Let's write the 1 over 2 outside the bracket and draw in our two brackets. The square root of a squared is a. Put a in over here and a in over here. The square root of 16 is 4. So I'm going to get 4b over here and 4b over here. Now I can separate these terms with a plus sign and these with a minus. In this example, we have a common bracket, a squared minus 4. This is our first term, and this is our second. The bracket is in both terms, which means we can take it out as a common factor. Let's do this now. We have a squared minus 4, and we're left with 3a minus 7. Now, in 3a minus 7, there are no squares, so we cannot factorize this further. We're going to leave this bracket as it is. But here, we have a squared and 4. They are both squares. So we can factorize this expression further using difference of squares. Let's do this now. I'm going to draw in two brackets. The square root of a squared is a, so I have a over here and a over here. The square root of 4 is 2, so I have 2 over here and 2 over here. Let's put a plus 2 in this bracket and a minus 2 in this one. And don't forget the 3a minus 7. And we have now factorized this expression. I want to look at one more example. Factorize the following. 25a squared multiplied by a minus 3b plus 9 multiplied by 3b minus a. Now, these two brackets both include an a term and a 3b term, a minus 3b and 3b minus a. But in simple mathematics, we know that 1 minus 3 is not equal to 3 minus 1. So we need to change the order of this bracket around. In previous videos, we learned that to do this, we need to change the operation of the term in front of the bracket. So we can do this now. We can say 25a squared. Let's open our bracket, leave it as a minus 3b. Instead of plus 9, we're going to say minus 9. And because we've done this, we can change the order of this bracket over here. And it's going to become a minus 3b. Close the bracket. Now we have a term over here and a term over here. And each term includes the bracket a minus 3b. So we can take it out as a common factor. So I can say the bracket of a minus 3b. And I'm left with 25a squared in my first term minus the 9 in the second term. Now, a minus 3b, it's not a square. There is nothing else we can do with it, so we're going to leave it as it is. But in the second bracket, we have 25a squared and 9. They are both squares, which means we can further factorize this expression using difference of squares. Let's do this now. I have a minus 3b. Then I can open up two brackets. The square root of 25 is 5. The square root of a squared is a. So I get 5a. The square root of 9 is 3. So we put 3 in over here and 3 in over here. Let's separate these terms with a plus sign and these with a minus. And we have finally factorized this expression. Please look at more examples like this in our upcoming videos.